we want to represent the event A and B on a Venn diagram. Right, so A and B means the same thing as A intersection B. And that is the symbol for intersection. And by that, we mean the common region. That is the region that is common between A and B. So we want to draw a Venn diagram, and then we need to shade the region that represents A and B. I suggest you just get used to drawing your sample space first, S. Then A should be inside the sample space. B must also be inside that sample space. So A and B means the common region, and clearly that should be the region that is common between A and B. Intersection means common. All right. The second part, it says not A and B. Not A and B means it's outside A and B. And you can actually write not A and B using some symbols. You'll be meeting these symbols. So this is how you write not A and B. And means intersection. So it's A intersection B. Complement. So instead of saying not A and B, I can say complement of A and B, or complement of A intersection B, or A intersection B complement. Right, so let's represent that region on a Venn diagram. So now you have your sample space, you have your A and your B in there. Right, we know A and B. A and B is the common region, let's call it number 2 there. That region number 2 there is your A and B, but we want not A and B, which means the complement of A and B. So that should be everything else except the 2. So we can just shade everything, totally everything except that region there where there is a 2. So your answer here will be everything that is outside that region marked 2 there. Okay, so wherever I've shaded there, that represents the complement of A intersection B. Here's another example. We want A or B. A or B can be written as A union B. So union implies that we will take all the outcomes of A and the outcomes of B and put them together into one set. And so they form a union. They'll form a union. So to draw that one there, once again, start with your sample space, then draw your A and your B inside the sample space. Then A union B means everything in A together with everything in B. So everything in A should be shaded and everything in B should be shaded. You will notice and agree that we just need to shade everything that is inside A and clearly everything also that is inside B. So that shaded part there is called A or B, or A union B. Now when we come to the second part, it says not A or B, which means the complement of A or B. So remember, not A or B means A union B complement. That is not in A union B. So if this here shows us what is in A union B, then that one there should show us what is not in A union B. And so clearly your set for this should be everything that is not shaded in this part. Everything that is not shaded in that part. So we just need to shade this region here. So it's everything that is outside B as well as outside A. So now the shaded part is the complement of A or B. Because remember, this is A or B, and so this is not A or B. All right. What about A and not B? A and not B. Okay, let's draw the sample space. Then draw your A inside the sample space and draw B, not B, but draw B inside the sample space, because not B means outside B. So the best thing is to draw your set B or your event B, and then not B is whatever is outside. So now this says A and not B. If you see it, you can shade it straight away. If you don't see it, you can do it step by step. A means everything inside A. So you could shade everything that is inside A like that. Not B means everything that is not inside B. So I'm going to use red and shade everything that is not in B. So what is not in B? I could use vertical lines now. So all that is not in B, everything that is not in B. I'm shading everything that is not in B. All right, so it's everything that is not in B there that is shaded. And I'm looking in this case for the intersection. Intersection means the common region. So what is common? Common is obviously where the blue meets the red. So where does the blue shading meet the red? Look at that diagram. You will notice it is here. I'll call that one 1. But you can draw it afresh. Draw it clearly here. So the region we are looking for, I'll make it green, is just that region there inside A, but not in the intersection of A and B. So this is what we mean by A and not B. Remember, A and not B can be written as A intersection not B, but not B means B complement. So this is the same thing as A intersection B complement, which you can read as A and not B. Okay, so these two mean exactly the same thing there. Okay, we have time for another example. Show by shading the event not A and B. Not A and B. Not A, remember, means a complement and means intersection. So this is another way of representing that event. You can use not A and not B, but you can also say A complement, intersection B. You draw your sample space. You're going to draw event A. Do not draw event A complement. A complement means outside A, so draw A so that you can identify outside A. And then another event B. Then A complement, not A. Not A means everything that is not in A. So what is not in A? I'm going to shade everything that is not in A. I'm going to use blue to shade everything that is not in A. So I'm shading outside A. All right, so that is not in A. Then it says B. B means everything inside B. So I'm going to use red to shade inside B. So this is inside B. Good. And then the question says intersection. It says end. End means intersection, which means we should be looking for a region where the blue and the red intersect. Look at your diagram. You will notice the region we are looking for. Let me call it number 3 there. Is that number 3 there? So let's draw it clearly here. So the answer that we are looking for should be that thing inside B, but obviously not in the intersection of B and A. Okay. One more. We want not A. Not A means A complement and means intersection. Not B means B complement. So that is another mathematical way of writing not A and not B. A complement intersection B complement. Start by drawing your sample space. Draw set A inside and draw set B inside. All right, so not A means outside A. So let me use red to shade outside A. So outside A is everything that is outside A. Just everything that is outside A. So that's everything outside A there. Okay. Then B complement means outside B. So I'm going to use blue and shade everything that is outside B. Everything that is outside B, that is outside B there. All that is outside B. All this is outside B. Okay, that's outside B there. Okay, so all that is outside B. We are looking for end. End means intersection, which means common. So we need a region where the blue and the red intersect. Look at that clearly and see what region that is. You will notice the region we are interested in is not inside A, it's not inside B, it's actually outside. I'm going to call that one number 3. Okay, so if we draw that so that we see it clearly, we've got our A here and we've got our B there. The region we are looking for is everything that is outside B as well as outside A. So that is the answer for that set there. That is not in A and that is not in B. Okay. One last one. Not in A means A complement. Not in B means B complement. But remember, O means union. So we can write this thing as A complement union B complement. Okay, start with your sample space. You draw set A and you draw set B inside. A complement is outside A, so let's shade outside A. Just straight lines will be fine. That is all outside A. B complement means outside B, so let's shade outside B. Now that is outside B. Okay, that is outside B there. Good. We are looking for union. Union means put them together. The outcomes of A complement and the outcomes of B complement should be put together. You should bring them together to form a union, which means in this case, everything that we see that is shaded is actually our answer because we are just combining them. We are not looking for the common region only, we are combining them. Okay. So when we say A or B, we mean A or B or both A and B. But in this case, it's A complement or B complement, which means A complement or B complement or both A complement and B complement. If you look carefully from this diagram, the answer that we are looking for is everything that we see there that is shaded, which means we will actually shade everything. The only thing that we are not going to shade is that number 2 there. And so if you want to show clearly your answer, you can just do this. You're shading everything except the 2. So it's except the intersection. Right, so all that should be shaded. Okay, all that should be shaded except the intersection.